Hi there. Welcome to another exciting session on AI agents. In our last two sessions, we explored AI agents and multi-agent collaboration, how they interact and work together to solve complex problems. One of the biggest challenge with AI agents is evaluating whether they are performing as intended. Unlike traditional software, AI agents are not deterministic systems. The same input can yield a different response each time. It could be correct response, but it could be slight variability in the response. This variability makes debugging and optimization more complex. That's exactly what we'll focus on today. How to evaluate AI agents effectively. So I will walk you through an end-to-end journey right from creating agents using LangChain, orchestrating them using LangGraph, and evaluating their performance using LangSmith. So we will also dive into the code and see a working demo of a use case where a company that wants to analyze its campaign performance and effectiveness using AI agents. So stay with me till the end. This session is packed with insights and hands-on learning. With that, let's get started. So let's get to this concept of AI agents in more details. So AI agents are more than just chatbots. They are intelligent systems designed to dynamically process user inputs and determine the best way to respond. Let's break down their core components. The core is that agent, which is a decision maker, which is a brain of the system. It takes a user prompt, analyze the intent, and decide how to respond. But unlike traditional software that follows a predefined path, right? Rules like if you write an API, if you ask, okay, if this particular condition satisfies, take this action. If this condition satisfies, take this actions. Agents doesn't work in that fashion. Basically, they decide what action, what path to take based on the user input. So for example, traditionally, if you're writing some API, say for some, some order management, some inventory management, you say, okay, if the order is in this status, take this action. Order is in this status, take this action. But agents not like that. They work, they see based on the user query, they take a appropriate action. So to do this, agent leverages two key elements. One is memory, which helps the agent to retain context across interactions. Second one is tools. Tools allows agents to perform specialized tasks like fetching data from database or running API query or even running an ML model. So agents doesn't have all the knowledge built in, right? Instead, they rely on external utilities called tools to retrieve and process. So this could be anything. For example, if you want to retrieve the data from local database, they might use a database tool. If you want to retrieve some unstructured data and do some semantic search using a RAG system, they might use a RAG tool. Or if you want to get data about your competitors or some other real-time information using a web API, they might use a web API tool. Like what tools to use, they will decide based on user intent. They might use one tool, they might use two tools, they might use more than two tools or all available tools to do, specific user tasks. So how does agent choose which tool to use? Right? For example, I'm having agent with three tools. One which to get the data from local database, another to do a search from the rack system, another to do an external API call. Take an example. How does user it decide? It basically understand the intent. For example, if the user is asking, compare my campaign with the competitor's campaign, it knows that it has to use a database tool to get the campaign information from the local database, and then it knows that it has to invoke a web API to query the web to get all the competitors campaign information and then merge both of them and then provide the insights to the user. This dynamic selection of tools makes agents more adaptive and capable of handling diverse real world scenarios, so that as a someone is developing, you don't have to factor in every scenario where user can ask a question. User can ask any questions, but I am giving a broad set of tools for agent to work, like a database tool, a ML model tool, or web API tool, and agents will decide what I should use based on the user prompt. This is what makes them more diverse, more adaptive, at the same time very challenging to evaluate their performance or their functionality. As we discussed in the previous slides, AI agents are not deterministic system. As I told, like depending upon the input, the processing will change. Like depending upon the input, there will be a dynamic decision making what path I should take. And then there is a variability in the processing, and then even output generation will change depending upon the user prompt. And we will actually walk through all the different examples, and I'll show you what path agent took for each user query response using a LangSmith. That's where we use a LangSmith to evaluate this. So in the coming slides, I'm going to walk you through, like it's for a specific prompt, how agent decided what tools to use. So we'll start with an AI agent. We'll configure some tools for the agent. We'll have an orchestration in place, and then we'll run some queries, and then we'll see how the agent responds for different queries and what tools it picks based on the user input. So before we get started, let's understand the use case which we are using for today's demo. So no technology or no framework agents doesn't add a value if it is not addressing a particular use case or business case. So the use case for us today is about a fictitious company called FitSense, okay, which is in the business of making the wearable devices like Fitbit and Apple Watch, and its main competitors are Fitbit and Apple Watch. And what we're trying to do is that we're trying to do some campaign insights. So this company ran multiple campaigns over a period of years, and they would like to understand like how each campaign performed on different metrics and different parameters. And they also want to understand like what are some of the best practices we could leverage based on some learnings, some internal documents that companies has. And third objective is that they also want to understand how about their competitors, like what all the products of competitors like Fitbit or Apple Watch are compared against their products, and what campaigns is working for competitor, what campaign not working. Like they just want to get different insights about their campaigns. So with that, let's see like what data we required for this particular use case. So let's talk about the data sources. Just like as a handyman as good as the tools he uses, any AI agents is as good as the data it is using. So we are considering three sources of data for this particular use case. The one, structured data, which is there in the MySQL database, which has got all their previous campaign information, like how many campaigns they run, what type of campaign, the channel, the number of clicks, impressions, the revenue generated, what is the cost of the campaign, like they're having host of parameters about each campaign. That is more of a structured data. And then they're also having an unstructured data, which is like some of the campaign best practices, some of the guidelines, some of the brand guidelines for a particular brand, how to position the brand, like a host of documents, internal document, which are the company specific. Okay. And third is the external data, which is the competitors data. So what we are using for structured data, we're storing all the data in a MySQL database. Okay. Unstructured data, like the company's internal documents, like best practices, the some of the guidelines for positioning their brand or for the campaigns in a vector database called ChromaDB. And third, to get the competitor information, we're using three external APIs. One is a Twitter or X API to get the sentiments about the competitors' products, and we are also using Reddit, like some other forums in Reddit, to see like what users are talking about this particular product. And then YouTube, like what all the videos on the YouTube, like what comments are for this for this video, like how many likes, how many dislikes, so that we know like how competitors are positioning their products in the in their campaigns. So the first agent we're having is campaign agent. This is kind of a strategic planner. This gives insights into their campaigns. Like if user asks a question like what is the CTR on my this Facebook campaign, or how does the Facebook campaign compare to the campaign I ran on Google, or the campaign I ran on Instagram, right? So it can give you that intelligence within based on their campaign data. So it uses two tools. One is it can also give information about their best practices, their brand positioning strategies, and other internal documentation what they're having. So it has got two tools. A one tool which is to fetch the data from the local MySQL database. Another tool to query the RAG system, like it has to query the ChromaDB and then get the data, unstructured data. That is the two tools it uses. And then once, depending upon the user query, it can use either a MySQL tool or a RAG tool, and then once it returns the data from these two tools, it will actually analyze the user question based on the data it retrieved. So the process is user queries, like for example, what is my Facebook CTR for this month, like conversion ratios for this month, what is my ROI for this month. Now it knows that to get this campaign data, I have to use a database tool, a MySQL tool. Okay, that tool can take a user query and then convert user query into a SQL query and then run with the SQL database, get the results, pass it on to the agent, which will see now the user question, and it has got the data. Now it can answer the question. Right? This is what this campaign agent is going to do. Now I'll quickly walk you through the code of the three different tools, how we configure the tools, how we actually tell the agents to use these tools. A quick code snippet to give an idea of how it is being done in LangChain. And then we'll move on to a demo. We'll see actually the agent one in action, and we'll see how agent one has chosen his tools in LangSmith. So before we go into the actual demo of the agent one, let's first see a code snippet. The full code is available in the GitHub repo. You can clone and see it. But to just give an idea, this agent, we are configuring two tools. One is a dynamic campaign SQL tool. What this tool will do is it will convert user prompt into SQL query and then run the SQL query against a database and get the results. For example, if you say get me all the campaigns I ran this month, it knows that it has to convert this into, say, a SQL query like select start from this table where date is equal to this and this. Or if the user says how is my ROI on Instagram campaign, it knows that select this ROI from the campaign table where channel is equal to Instagram. So it can convert a user prompt into a SQL query. How we do that? This tool leverages again in LLM. A prompt will be given. We tell, okay, this is a database, this is a table you will be using, and then you need to generate a SQL query based on this particular user prompt. Second tool we are giving to this agent is a doc retrieval tool. This tool will actually fetches the documents from a RAG based system. So if the user want to know like some of the campaign best practices or some of the lessons learned from previous campaigns, what worked, what not worked, or some of their guidelines and brand positioning, then it can retrieve that. Based on that type of user queries, it can go and retrieve those documents from its internal unstructured database from ChromaDB. Now we are giving these two tools to these agents, and then we are saying you are a helpful AI assistant that helps with analyzing the marketing campaigns, so you have access to these two tools. Now agent knows that it has to pick up one of these tools. It cannot go out of. Sometimes this also helps in reducing the hallucination of the AI agents, so that now we are giving very structured context for the for the agent, like this is a user question and this is a context. So when you give a better context for the agent, the chances of agent hallucinating will reduce. Now we run this agent. Now agent will take the input again. Now when you say when you run the agent, it will decide based on the user input to pick up one of these two tools and then execute the tools and then provide the output what user required. Now before we go to the second agent, we'll first see how the agent 1 functions. Like we'll see some examples of agent 1, and then I will also walk you through how this agent 1 decision is being made. We'll also see the LangSmith where we can actually visualize the path agent has taken. Okay, now let's see the campaign AI in action. So we'll first focus on the demo of the first agent. So the first agent is which is giving us the campaign insights, right? So this UI is developed in React, and this React UI invokes a fast API, which the fast API in turn invokes the agent. So to start with, before we start, let's look at the data what we're having. These are data in MySQL where we are having the campaign data, which is all the host of campaign information. This is all synthetic data I generated for testing this application. So this is all campaign data. Now user want to get some insights into this, campaign data. Now we'll ask like which campaign has got highest conversion rate. Now this agent is actually querying the local database. It is converting this query into a SQL query and then executing that, and then this giving like the marketing campaign highest conversion rate is this Google awareness campaign, which has a conversion rate of 9.98%. Of course the data is also synthetic data, so we can always debate like the conversion rates. But what is the most important thing is that we'll now go to LangSmith UI and then check how this particular AI has performed this path. So now this is our campaign AI. Now it will list all the queries you ran, and then what is the input, what is the output, what is the start time, what is the latency, what is the data set has been used. Now this is what we just ran, right? So our question was which campaign has got highest conversion rate, and then this is what the output given by the agent. Now the point is, how do we decide this? Okay, I think we are having a supervisor agent. I'm going to walk it through later, but now you can see here that what is the I'm using GPT 3.5 Turbo LLM. It will tell you like what is the cost of this particular running the query, how many cents it has cost. But key thing is that it is showing you that okay, this is what the tool it has selected, right? So it now we can see that it has converted my user query into this particular SQL query. Okay, and it is again refining it again, and then in the end it is executing this query. Okay, it is, see, if you can see that actually agent is doing some thinking. It is actually executing the query, and then it is actually selecting campaign name, round of conversion rate. It is clicks by as conversion rate from campaign, order by so and so. Now the output it is getting, it is passing it back to the LLM, and then GPT is, if you see the output from this tool is only this 9.98, that's it. And the agent is what it is actually converting this into the actual text. So this, and also I want to show like how do we, what is the prompt we give to the SQL tool. So we are telling SQL tool you are an expert interpreting SQL results for marketing campaigns. So given the original user question and SQL results, create a clear concise summary, right? Now it has created, based on that we gave all the my prompt. It has converted that SQL query and then it is giving it back, and then LLM is actually summarizing that. Now we can see the path the agent has taken. So now this will make your job easier to check whether the agent is working as intended. So of course in the end we are also going to run some of the test cases. Just like you run a traditional test case, we will run some evaluation steps in evaluation jobs which will check the agent final output on multiple queries. Now let us try some other agent, some other question, like maybe I would ask what are the best practices to run a campaign, right? Now it has now it should use a different tool. It has to get the data from internal database, the drag system, and then display the results. Now basically now we'll see like yeah, it has got some of course I have very limited synthetic data, so you are seeing very limited data over here. But the key thing is that it has chosen the RAG tool. Now we'll go back to LangSmith again, and see like what is the path it has chosen. Now these are question now. Now you can see that this time it has used a doc retrieval tool instead of using the SQL tool. So if you see our code, we are not saying if this is a question, use this tool. If this is a question, use this tool. We are just giving agent the tools to use, and agent is making a determination whether which tool to use based on that user question, right? So now it has used Docker Tribal tool. So this is the basically the agent one, okay, where it has able to retrieve the multiple, answer multiple user questions and then choose a right tool based on user input. Now we'll see the second agent, which would actually helps us to understand the competitors information. So now let's look at our next agent, which is a competitive intelligence agent. This agent main task is to get the competitive information about, like its competitors, like, in for our case, we are having Fitbit and Apple Watch as a competitors. Now we are actually going for asking different tools this agent is using. One is a X tool, which will get all the tweets, sentiments about the competitors product from X, and Reddit tool, which will actually go and check some of the forums in Reddit about any reviews for the competitors products, and also YouTube tool, which will go and fetch all the data from YouTube, the videos and some other comments, and also a price comparison tool, which is basically I'm having some internal, kind of a JSON where we are having all the comp like Fitbit and Apple Watch prices, and then we're trying to see like how the price are compared against the competitors. It follows same path. It takes a query submission. Depending upon it will determine whether it requires all the tools or it requires what tools. If you're asking for a price comparison, it might go for a price comparison tool. If you're asking for how my competitors are performing against others, I might use all the X, Reddit, and YouTube tool. And of course, all of them comes with a free API key. You can go and get them. Just that challenge with X is that it has got a limited number of posts you can retrieve per month, on the free tier. But others, Reddit and YouTube has got a generous, free tier. Um, so let's now we look into the how the code snippet for the agent 2, like what tools it is using and how it is being using. So now, just like other tool, here also we're having four tools in this agent. We are having a Twitter tool, which will get the sentiment analysis from Twitter or maybe X, and other one is Reddit tool, which will get all the user discussions from the Reddit forums, and a YouTube tool, which will actually get all the YouTube videos, that number of likes, dislikes, comments, and a feature tool, which will compare the features or the prices from the competitors. Now for this agent, we are giving all the four tools. So now it can use one of the tool or maybe two or three tools, or maybe all the tools depending upon the user query. That's what we'll see in the next demo. When we see how this agent is doing, we'll see in our actual when you do the next demo. So I also want to show you how to enable the LangSmith. I was showing the LangSmith UI, but for you to get LangSmith, you just need to go and sign up. You get a free developer account. You get API key. All you do is at the top of your agent, just set these three variables. You set the LangSmith API key in environment variable, say set trace is equal to true. You give some name for your project, like any name you give, so that when you go to LangSmith UI, all the traces what you have enabled are actually under that particular name. And maybe in the code also you have to give us which wherever you want to trace the method or function, you just add that enable the traces for that method, then it will start logging all the traces into the LangSmith. Okay, now let's test this competitive intelligence agent with some other prompts. For example, maybe I want to check, I ask how are people responding to the new Apple Watch, Ultra features. Okay, now it has to use the available tools like Twitter, Reddit or YouTube to get the insights about the Apple Watch Ultra features. Let's see what this agent will do now. So I'm just clicking get insights.
Now, of course, it has to go to all the three places like Twitter, Reddit, YouTube, get the documents, insights from all these places, and then pass it to LLM. LLM is going to summarize and then giving. So now it is making all the API call. That's why you could see a slight latency compared to the previous tools. In previous agent, you were actually hitting the local database or local Chroma store for unstructured data, but now it is actually making the web API calls. Now it has got all the insights. So now it has got insight from Reddit, the what is Apple Watch, the analysis from Reddit, what is YouTube analysis, and is saying overall sentiment, and it is also giving the sources. It is just not telling you this one like where it has got all the data. It is showing the subreddit form, some other YouTube, I think, yeah, one, this is not giving actual YouTube channels, but maybe we can configure the prompt to give actual YouTube channels. Now, let's go back our LangSmith again and see like what tools, what path this agent has taken. Okay, now this was our question, right? So this was the total number of tokens, the latency, and then the cost. Now it can see that it has used this many tools because now the question is how are the people responding. Now it has to see from all this like Twitter analysis. um, yeah, maybe Twitter I exceeded the number of posts for this month, so that I read the cap. But we could see that Reddit analysis, it actually done all the Reddit analysis. You can see all the traces. Basically this AP tool is dumping all the data from different Reddit posts into to the agent, and agent is summarizing. If you see, this is the output this tool got. And then, but if you see actual output, agent actually summarized this into one concise paragraph, right? That's what the beauty of having agents and tools. Now it is also using a YouTube analysis tool and function. Now you can see that this is actually output, like it's showing like how many videos, how many views, and what all the video. But the agent actually summarized the all the information into one concise paragraph so that it will be easier for you to read instead of dumping with all the information. Now this is the path it has taken for this agent. This is giving you a competitive information. Now there could be scenarios. Now this is where we need to orchestrate. Now we develop these two agents using LangChain, right? LangChain, you develop two agents. One is a campaign intelligence agent which will give you the campaign information locally. Another one is a competitive intelligence agent which will actually give you the competitive information. Now, there could be scenarios where I want to get the information from both. So I want to have an orchestration layer on top of these two agents, which will tell me, hey, if the question is this, you have to use this agent. If the question is this, you have to use this agent. If the question is this, you have to use both the agents, right? That's what the supervisor agent is going to do, and then we'll check the supervisor agent next.
Okay, now we'll see our final agent, which is a supervisor agent. This is where our orchestration layer was. So far you have developed these two agents using LangChain, which is a framework to build the agents. But LangGraph is a framework to build that orchestration. Now, depending upon the user query, I want to redirect into one of the agents. The user is asking about the local campaign data. I want to redirect them to campaign agent. If it wants a competitors, to competitors agent. Sometimes it could be that compare my campaign with a campaign run by say Apple Watch or Fitbit. Okay, now I can combine the data from our campaign data from the competitor campaign data and give some insights, right? This is where the supervisor orchestration comes. So there are multiple ways of orchestrating. Like you could have a supervisor age orchestration, a hierarchical orchestration where you have one supervisor agent, give the task to two agents, collect the information from both and then outputs. Or it could be sequential. Each agent will execute, give the back to the user. Supervisor might simultaneously give the task to more than one agent. Each agent will perform its task and give it back to the supervisor, and supervisor will actually merge all the data from all different agents and then produce one single output. So we could follow a different pattern, or sometimes it could be very simple. Supervisor knows, okay, this is a user query, go to this agent. This is a query, go to this agent. That's what we are doing in the using the LangGraph. Now this is a LangGraph code. In LangGraph we have a concept called nodes and edges. So nodes are nothing but all the agents you developed, and edges are how you actually want to orchestrate. So I have added two nodes. One is a decider node and then executor node, and then basically we decide which agent to invoke, and then we have an execution taking place. Now here we are trying to decide the route, like depending upon the prompt we are telling that you are having two agents. One is a campaign agent, one is a variable intelligence agent. So you are to decide based on user prompt. So basically it returns only three things, whether you three words: campaign, variables, or both. So depending upon the word it returns, the next agent execute invoke the appropriate agent depending upon what input it gets. So previously I didn't show you the decide, the supervisor agent. Now let's see how the supervisor agent, for example, let's go back to the original question what we asked, which campaign has got, highest conversion rate. Now these of low, it went to first decide agent, okay. The next step is decide, okay, and then this agent replied back saying that you should take the campaign route, okay. Now based on the campaign route, the execution started. Execution set agent route is campaign, next step is execute, then it has actually invoking that corresponding agent. So this is the supervisor agent doing. It is deciding which agent to invoke, and then based on that it is actually invoke executing. So you can see that the human message, the output, in fact, you can see some metadata for this particular feedback agent, how it is doing. Then you can see some execution agent. So basically this is how we can actually orchestrate using the LangGraph. Now so far we have seen a building agent using LangChain, orchestrating using LangGraph, and we have used LangSmith to see the traces of what path agent is doing. But sometimes we need to run a structured evaluation steps where we have some pre questions, and then we say for this question what will be the my answer, right? So for that we have got something called evaluation jobs, okay, so which you can run offline. So I ran some evaluation jobs. So basically there are multiple evaluation jobs you can run. One of them is LLM as a judge. So what it means is that when you run a agent, you give that output to another LLM and ask it, okay, this is a question, this is the output, do you think this output is correct? That's LLM as a judge. Another type of experiment data set we can run is a trajectory analysis. For this question, the agent is supposed to take this trajectory, like, for example, the conversion rate, it is supposed to go to the campaign. It has to first go to decide, execute, and then campaign. If it is a competitor, it has to set decide, execute, and then to the competitor agents. Is it taking that path or not? So we can, we have some set of LangSmith API, to run this type of jobs experiments. So I ran one experiment with campaign analysis, final response type of agent. Now before we go, we give some examples to that particular agent, like we have given example, okay, which campaign has got a highest conversion rate. So I'm saying that for this one the output is this, and I'm actually before that I'm giving some reference output, right? So the campaign conversion rate is this one. So basically I'm telling, if this question is this has to be the output, or something similar. The question is this has to be the reference output. So I'm giving all the reference output to the agent, to the my experiment. Then I'm running experiment. Now when I ran this experiment, so for example this was my question, okay, how are my Facebook campaign CTR this month, click through rates. Okay, now it has given me the output as 3.10. Now it shows me all the linked runs. Okay, then it shows me all the path it has taken. Now I know that what trajectory it has taken for this particular question. I can evaluate whether it has taken a correct trajectory or not. Now I have asked another question, which is what is ROI and Google ad campaign. It give me this campaign, this one. Now I'm actually, this is what my reference output is, this is my actual output is. Now I'm comparing how close this is. For example, in this case, you know the you can see that even though there is not exact match, it can figure out, like we are giving a reference output. Okay, this is reference of my, for example, my reference output is the camp. Yeah, this is my, like, what is ROI and Google ad campaign. My reference output is this one. This is what I told agent that you should expect this type of answer, but I got a slightly a different answer. Still it is passed in this test case because it knows that these two are very close, they are not. If I run the same data set again second time, I might get a different response. Similarly for this one, you can see here, like which campaign has got highest conversion rate. I gave this particular response, and it gave me pretty much exactly very close to the actual reference output I gave. So now it is also showing what is the latency, what is the status success. For example, if the reference output and then actual output is different, it will fail a test case, it will be failed test case. Now you know that in that case you might have to go back and check whether there is something wrong with your prompt or something wrong with your trajectory it is taking, and then based on that you can analyze. So this is how you can actually use LangSmith features to test whether the agent is performing as intended. Okay, thanks for watching, and stay tuned for some more updates and exciting features on AI agents. Thank you.